All right. In this video, I'll be taking us on statistics, that is on regression analysis. We are going to take the definition of regression analysis and then also the calculations on regression analysis. So let's take the definition of regression analysis. Please let's take a note here. This right. Regression analysis can be defined as the relationship between the dependent variable and independent variable. Regression analysis can be defined as the relationship between the dependent variable and independent variable. Okay, now we are going to know what this dependent variable is, and we are going to know what this independent variable is. Okay, please take note. So when I was saying about dependent variable here, though the letter that stands as dependent variable is y, that is y stands as dependent variable. Please take note. Y stands as dependent variable, or you can call it respond variable. Please take note. Or you can call it respond variable. And the letter S, please take note, the letter S stands as independent variable, or you can call it explanatory variable. Please take note of this. Okay, now we say that the letter that stands as dependent variable is y, so dependent variable is y, yeah, or respond variable, while independent variable or letter is s, or explanatory variable. Please take note. Okay, now after then here we have to know the formula that relates the dependent letter, which is y, and the independent letter s. Okay, but before that, let's take the first regression analysis, which is said to be linear or simple regression analysis. This right? Linear, simple, or linear regression analysis. Okay. Linear or simple regression analysis. Okay, in this video I will focus on linear or simple regression analysis. So when we are saying about a simple equation relating to x and y, we have that formula to be y is equal to ms plus c. This is the only formula that relates s and y in a simple equation. That is y is equal to ms plus c, where this coefficient of s is said to be the slope, while this part here is said to be the intercept. Okay, now from this equation here we can easily form the formula for regression analysis. Now the formula for regression analysis from this analogy, that is from this relationship here, is said to be y is equal to beta 1 of s. That is the equation said to be y is equal to, from this analogy here, that's y is equal to beta y, y is equal to beta 1 of s plus beta naught. Okay, in this equation here, we call it equation of best fit or regression line equation. Okay, in this equation here, we call it equation of best fit. This is called equation of best fit. Okay, this is called equation of best fit or regression equation. Equation of best fit is called equation of best fit, or you can call it regression line equation. So why is it called equation of best fit or regression line equation? Because it shows the relationship between the x and y. The x and y, please take note. But in calculating any parameters, remember ys is said to be in this particular formula here. Y is said to be dependent or respond variable. S is said to be independent or explanatory. But this beta 1 and beta 2 is said to be regression coefficients. Okay, this beta 1 and beta naught, remember beta 1, sorry for this, okay, beta 1 and beta naught is said to be regression coefficient. Please take it. Beta 1 and beta naught is said to be regression coefficients. So we have known what regression line equation is. We have known what regression analysis is, and we have also known what equation of best fit is. Okay, so now let's know how to calculate beta 1 and beta naught, because when you find the value of beta 1 and beta naught, that will lead us to this particular equation here. When you find this beta 1 and this beta naught here, you can now find the relationship between y and s. Our intention here is to find the relationship between y and s. Okay, please take note. But before them, let's try to know this, that this coefficient here, that's beta 1 here, the coefficient of s stands as slope from here, from this particular equation here, equation of straight line, that this is slope, that is this is slope, this is intercept, that this is intercept here. Okay, now let's try to solve, or let's try to know how to solve any equation on regression analysis. Okay, now to solve any equation on regression analysis, we have to use the equation called estimation equation. Please just understand this. To solve any equation on regression analysis, we use estimation equation. So now let's know what estimation equation is. Okay, let me clean the board. Okay, okay, now class, let's know what estimation equation is. Remember, for us to calculate our beta 1 and beta naught, we use estimation equation, not equation of best fit or equation of regression or equation of regression, okay, we use estimation equation, as the name implies, estimation equation, okay. Now, what is estimation equation in terms of regression analysis? Now, the equation is said to be y bar is equal to beta 1 hat, please take note, s bar plus beta naught bar, please take note. That is y bar is equal to beta 1 hat s bar plus beta naught hat. Okay, now the s bar and the y bar is said to be mean of s and y respectively. Is said to be mean of s and y respectively, while the beta 1 and beta naught hats is said to be estimation coefficient. That is estimation coefficient. Please take it. So now let's try to understand more about this estimation equation here. So if I have this equation here, this is said to be the mean of y. That is this one here, is said to be the mean of y. That means if y is given to me, I plus up and divide by the frequency. This is said to be the mean of s. That is, if s is given to me, I plus up and divide with the frequency y. That means if this is given, that is mean of y is given, mean of s is given, and maybe this guy is given here, I can easily find this particular one, right? Listen to me carefully. If this is given, mean of y is given, mean of s is given, and this guy is given, I can easily find this one here. Alright, now we all know how to find the mean of y by plussing the values of the numbers of y divided by the frequency. The mean of s plus up the numbers of s divided by the frequency. Y beta 1 has a formula. The formula for beta 1 here, class, the formula for beta 1 is said to be this. The formula for beta 1 is said to be beta 1 hat is said to be n sum of sy minus sum of s sum of y divide by n sum of s squared minus sum of s or square. So what does it mean? It means that I have to find the sum of sy. That means after knowing our sy, I have to find the sum of s and I have to find the sum of y. Okay, this m here is the frequency of s and y. That is the pairs of s and y. Okay, the frequency of s and y. So how many numbers in s, how many numbers in y? Okay, so the same thing here. This m here is said to be the frequency of s and y. Okay, this one is said to be the total of s squared. That means I have to have a table in s squared and total them. I will have this. Why this is different from this guy here? This one is different from this. This means the sum of s, you square the value, you have this one here. Please take it. So let's try to solve the equation here to understand this topic perfectly. Okay, example 1 please. Example 1.